Okay, this is the video. Going. All right, so yesterday we started to discuss concave up and concave down. That's where we ended things. I think I'm actually just going to redo this slide just so we can discuss it one more time. Concavity, it says, critical points of a function are those at which the line drawn tangent to the curve is horizontal or vertical. Yeah, what does that even mean? Okay. Extrema are critical points at which the function changes from increasing to decreasing or increasing or decreasing. At these points, the function has a maximum or minimum value, either relative or absolute. A point of inflection can also be a critical point. At these points, the graph changes its shape, but not its increasing or decreasing behavior. Instead, the curve changes from being bent up or being bent down, or vice versa. Okay, so what I discussed yesterday was if we have a graph like this, there's a relative maximum, a relative minimum, and somewhere in between those, it changes its concavity, okay? And that's going to be called an inflection point. And we are going to estimate where that inflection point is. Now, when I say estimate, the point you pick still needs to be part of the graph when you're doing it on your calculator. You just can't randomly go, oh, I think that's 1, 2, and have 1, 2 be like over here somewhere. It needs to be a point that's on the graph. Does that make sense? All right. So concavity, again, this is concave up, either that bend or that bend. So I always talk about it as the happy face. Okay, this is concave up. The video also didn't record this yesterday for some reason, but it recorded the rest, but it ran out before it got here. Apparently I don't have enough room on my hard drive. All right, this is concave down. And this seems like a really easy concept until the graph looks more like this up here. Do you see how it's kind of hard to tell what's going on? If you look at this little piece, can you tell that that's supposed to be concave what? Up. And then over here, this little piece would be going down. Okay. Inflection points are always going to be estimates, and they're going to fall between, I can write that, the maxes and mins. All right. Can I go on? Anybody need more time on this slide? All right. So here's a picture. Let's just review a little bit from yesterday. Is this an absolute or a relative max?
Relative.
This one is relative. This one is absolute. Everybody's good with that? Okay.
Yeah.
We're not going to spend a lot of time. I'm not going to ask you on the quiz. At this point, I've never asked which is it, okay? It's a good idea for calculus. This one, relative min because it's going down with arrows, right? Okay, what else we want to talk about? Yeah, we're good. I think we got it. All right. Okay, it says because calculus is needed to confirm the increasing and decreasing behavior, it's also needed to confirm the relative and absolute extrema of a function. For now, however, you can use your graphing calculator. When locating maximum minimum, be sure to zoom in or out in order to see details. Okay, the standard window may not tell the entire story. We've talked about that a lot. And we got started on this question, yes, but I don't know. How many examples of this do we have? You know what? Let's do this number 3, and then let's do some on that practice worksheet. Does that sound okay? I like the practice worksheet. Ooh, then we got to come back to this application. All right. What's going on here? What are the points we might need to estimate and label? This just count by ones. I just like doing these estimates. It takes so much time to find everything on the calculator. This goes faster. It looks like 0, 0 is a max, maybe. And one of the zeros. Where's the other 0 over here? 1.90. And this minimum we need to maybe label. I don't know, 1.2, comma, 1, 2, 3, -4. Does that seem right, guys? Okay. One more point we should probably pick is in between there we need a, remember what that called? Yes, an estimated inflection point. Guys, finding the inflection point is going to feel very uncomfortable for you because it is totally an estimate, okay? I will accept, you know, anything from here down to here, and it's not, the students always want to go, well, I'm just going to pick the point exactly between the max and the min. It's not always there. You can use that, I don't care, but that's not the way it works when you get to calculus, okay? What you're trying to see is where it changes from bending down to bending up. So I don't know. How about if we just pick right there? So let's call it 1, comma, -2.1. Does that seem okay? Again, really no right or wrong answer there. All right. I'm going to run through all the things I would ask you on the quiz. Let's start with zeros. Where are the zeros? And you can write them as ordered pairs on the quiz. 0, 0, and 1.90. All right. The max points. Any? 0, 0, is that the only maximum? Okay, min. 1.2, -4. Domain. Range. Everybody okay that it's -infinity to infinity as well? It kind of looks almost vertical here, but it's not. It will continue to go to get wider. You can put anything. Remember, domain is what can go in here and range is what can come out. So we could put incredibly large, weird numbers in here. We'd get out incredibly large, weird numbers. Okay. Okay. Can you tell me something about the end behavior? Let's practice that again. I'm going to use g of x notation because that's what they called it up here. But g of x as x does what? And you can start by doing the x first. I don't care. Okay, so if we say on the left, this graph is going, so -infinity, okay? All right. On the right, this graph is going up. So on the right up is infinity, infinity. We're good? Okay. Which of those could be the same? The g's of x's or the x's? The g of x, they could both be going down or both be going up, right? But the x's have to change. That's what I get when I get somebody's quiz and they said, as x approaches infinity, it's going down. As x approaches infinity, it's going up. You obviously don't understand the concept, okay? So, all right. Increasing and decreasing. Did we get that down yesterday? Do you remember? Anybody? No? Okay. So how do we decide increasing, decreasing? We look at the graph from left to right. That's the important thing, from left to right. So what is this graph doing from -infinity until the first maximum point? Increasing. And how do we write that? Yes. And were we using the x or the y there? Because there we can't tell. It's always x's. Okay, it's x's. Okay, we can come back to increasing if you want. There is going to be another piece where it increases. But the next thing it does is decrease from what x to what x? Everybody's good with why it's 1.2? This whole stretch in here, okay? And then it starts to Increase again from 1.2 to infinity. Anybody lost? And I'm not going to be picky about the u's, whatever. It's the y values that are actually increasing or decreasing. It's the x values that we want to state are causing the y's to increase or decrease, or does that make sense? Always an x value. All right, same with concavity, we state the x values. What's happening here about concave up or down? Remember, concave up and down changes at what point? The inflection point, okay? So the inflection point, we had an x value of 1, exactly 1. So to the left of 1, it was doing what? Concave down. Everybody okay with that? And again, this number has to come from your inflection point, which I never actually wrote the inflection point down on my list here anywhere. Should have put inflection point. Whoops, I can't spell either. All right, and then concave up. Be careful, it's not 0. It has to be off of the inflection point. See, this was still down, and then it switched up. 1 to the right, or infinity. Okay? So that's a trick you got to remember, is the concavity changes at the inflection point. All right. Let's do this application, and then we're going to go to those worksheets. A box with no top and a square base is to be made by taking a piece of cardboard, cutting equal size squares from the corners, and folding up each side. Sound familiar? Okay, this isn't going away. Suppose the cardboard piece is square and measures 18 inches on a side. Okay, is this different than before? What were we finding last time we did this question? Do you remember? The size of the original cardboard. Now we know the size of the original cardboard. All right, write a function for the volume when x is the size of the square we're going to cut out. So this little square is x by x. And we're going to cut it out of each corner. All right. So then we're going to fold it up into a box. How tall is our little box going to be? Yes, this piece we cut out and this piece here are going to become this height, so that's x. All right. If this used to be 18, what did we take away to make this little piece right in here? Okay, and it's not 2x minus 18 because we started with 18 inches and then we cut it down. And we got 2x because we cut an x off each side, yes? So this dimension of the box is 18 minus 2x, and this dimension is 18 minus 2x. Is everyone okay? This side would be the same over here. So what's our expression for the volume? Length times width times height. Is there a way we could write that, multiply all those together? X times 18 minus 2x squared. Can I just abbreviate that and simplify and everybody's okay? That's length times width times height. All right, we're supposed to find the maximum volume and what value of x maximizes it. This is a cubic. Guys, do you remember something about cubics? The shape of a cubic does this if it's positive. Okay, so does it really have an absolute max? No. But we can find a maximum, and there's a reason we can find a maximum, is it has to do with that relevant domain. I don't know if you remember that term, but look right here at this side of the box. How much of x can we take off? If we do 18 minus 2 times some number, 9 is the most that it could be. If this side is 18, we can't go in more than 9 this way and 9 this way, or we run out of room to cut. So our domain has to be 0 to 9. It can't be 0 and it can't be 9. I don't really care about that. What I care about is that that's how we're going to set our window. All right. So you guys are faster than me. Get this typed in your calculator. Oh, why does this always show up where I can't get to it? What's going on here? Okay, I started it like 5 times, I think. Okay, did you find an appropriate window yet? The domain is 0 to 9. The range is the volume of the box. We probably should plug a couple numbers in to see what we get. Let me see if I can do this in my head real fast. I'm sure I can't. If I put a 2 in, it would be 2 times 18 minus 4, which would be 14. 14 squared is almost 200. 200, oh, I already squared it. So 200 times 2, 400. So I'm thinking it's going up maybe 600 or 700. What did you get? Anybody? I'm going to try 600. Yeah, no, not even close to 600. Do I have it typed in right? Did I put this? No, I left off the squared. I was like, it can't be that small. Oh, 600 is good. It works. Do you see how weird that shape is? It's a piece of a cubic. Okay, that's why it has that funky shape. All right. We need to find the maximum real quick. Did anybody already find the maximum? I know you know how to do this. Between 0 and 9, what was the maximum? The maximum occurred when x is 3, and the maximum volume of the box is the y value of, yes. So the max volume equals 432 when x equals 3. What is the relative minimum of the function? Explain what this means in context of this problem. Well, the minimums are going to occur out here at 9 and at 0, right? Because you're not going to get a box. So I don't think we need to write that down. We're good. I'm not going to ask that on a quiz. Everybody good? Oh, the other part of this assignment is on average rate of change. Did we already do average rate of change? Do we kind of stink at average rate of change? Maybe. Average rate of change, remember you put the value into the function. You write what value you put in x, what value you got out in y. You put in 2 values and then you find the slope. So let's do one of these and call it a day. Which one do you want to do? I'm going to do 5. It's going to be more typing, but I'm a little worried about putting the negatives in. -3. Do this on your calculator, guys. $29, $19, anybody? Huh? $29? Okay. I think this is only like 1, isn't it? Okay. So what are our ordered pairs? We put in a -3 and got out a 29. And then we put in a -2 and got out a +1. So now we find the slope. I got negative 28. Did anybody get negative 28?